Section 1-2, composition and inverse of functions. All right, so this will be a little more review of algebra. All right, we're going to work on quite a bit of algebra here in this first section, just because our algebra needs to be sharp as we move towards calculus. So we're going to work on some skills. You've been exposed to these things, but it might be just a matter of refreshing your memory. So let's get to work. If we combine two functions, this is what this is saying is if we combine two functions, we're going to go ahead and instead of, function notation is f of x, all right? So this is saying f plus g of x. So this is saying we're adding two functions. So if I have a function f of x equals x plus 1 and and g of x is denoting a different function equals 2. All right, that's just saying that we're going to add those two functions together. This means that we're subtracting those functions. This means that we're multiplying those two functions. And obviously this means we're dividing two functions. One stipulation now is that if this g of x, it cannot equal 0. So like if I had two equations different from one up top, or if I just changed this one up top to x plus 2. All right. So if we were dividing this, it would just be x plus 2 divided by x plus 1. Or, no, sorry, my bad. X plus 1 divided by x plus 2. That's the g of x. That just goes down there. One stipulation is saying, well, we can't have an x value that's going to make the denominator 0. So we're saying x cannot equal 2 right away, right off the bat, before we simplify or anything. All right? So just giving you a heads up on that because we'll run into that here in a little bit. Okay? So example 1. Given two functions, f of x equals x plus 3 and g of x equals 2x divided by x minus 5. Find each function below. Name all values of x that are not in the domain of the new function. All right, that's kind of what we did in the last part of the last video. And this isn't too bad. So this just means we're adding those two functions together. So x plus 3 plus 2x over x minus 5. Now, we're asked to simplify this, all right, and then name all the functions that are not in the domain of the new function. Okay, so if we want to add these two, in order to add fractions, like if I have 1/2 plus 1/4, I have to have a common denominator, right, of 4. So I got to multiply this by both of those by 2 in order to get a common denominator. In the same way, I got to have a common denominator in order to combine these terms. So just underneath that is just a 1. My common denominator is going to have to be x minus 5. So what I'm missing out of this x plus 3 is x minus 5. So I'm going to have to multiply those two in order to combine like terms. So we can FOIL that out. All right. If we FOIL it out, first, outer, inner, last, right? I get x squared minus 5x plus 3x minus 15. That's first, outer, inner, last, right? Excuse me. All right. So we FOIL that, and now that we have a common denominator, we can add all these like terms. My common denominator is x minus 5. Okay. So now we can combine like terms. Now we can add, like just like up here, now we can add, we get 3/4. Now we can combine like terms. So now I have a positive 3x and I have a positive 2x. So now my result will be x squared because there are no other x squares to combine. And sorry, I have a negative 5x here. So negative 5x plus 3x is 2x. Plus 2x is 0. No, sorry. No, yeah. Negative 2x plus 2x is 0. So I don't have any x's left. So I have x squared minus 15 divided by x minus 5. So we've written the new function. The only thing left to do then in the directions is find the values of x that are not in the domain. All right? And that's what will make this domain undefined. What values of x will make this function undefined is what's going to make the denominator 0. So we'd say x minus 5 cannot equal 0. Add 5, add 5. X cannot equal 5. So that's A. B, we're going to subtract the two functions. It's going to be very similar. All right. So we're going to say x plus 3 minus 2x divided by x minus 2. And again, in order to subtract fractions, we have to have a common denominator. This is over 1. My common denominator, or sorry, x minus 2, I don't know where I got that. X minus 5, I apologize. All right? That's what this said up here. Okay? This is the f function. This is a g function, f minus g. All right? So I need to multiply those two. I need to get a common denominator of x minus 5 and I can FOIL out, and then I can combine like terms. So now I have a x squared. We've done this before. So first outer inner last, minus 5x plus 3x minus 15. And this time it's going to be minus 2. And in the case, minus 2x. In the case where we'd have like a 2x plus 1 or something like this negative sign would have to be distributed to every single thing on this side. So it would have been a negative 2x plus 1, if that would have been the case. So that negative sign has to be distributed through everything. All right? That's kind of like one of those we had on those that algebra review I had for you. All right? And then my common denominator is x minus 5. And now we can, again, combine like terms. This time, negative 5x plus 3x is a negative 2x, minus 2x is a negative 4x. So I have x squared minus 4x minus 15 all over x minus 5. And again, name the x value that can't be in that domain is going to be x minus 5. Or x minus 5 equals 0. So we'd say x minus 5 cannot equal 0 because we can't divide by 0. Can't have 0 in the denominator. It's undefined. Add 5, so x cannot equal a positive 5. Okay. F times g. All right. So x plus 3 times 2x divided by x minus 5. Again, this is no different than multiplying fractions. All right. When I multiply 1/2 times 3/4, I multiply straight across 3/8. I multiply top times top, bottom times bottom. This is just like it's being over 1. So when I multiply x plus 3 times 2x, I got to multiply this 2x by every single thing. So I have 2x squared plus 6x divided by 1 times x minus 5, which is x minus 5. And again, maybe we can simplify that. Maybe we can pull an x out. X times 2x, or 2x plus 6 divided by x minus 5. And again, name an x value that's not in the function, in the domain. Obviously, x cannot equal 5 because that would make the denominator 0. One thing that I do not want to see in this common, and I don't know why, and people like to do this, you cannot cancel these out. That x just can't magically disappear. All right? If we had another x out here that was being multiplied, then we could cancel out. But when this x is connected with a minus sign or a plus sign or something like that, we cannot cancel those out. Okay? And the last one here, f divided by g of x. So x plus 3 divided by 2x divided by x minus 5. All right? And again, like I said, we had that stipulation. We automatically can't have this value that's going to make this denominator 0 because that would make it undefined. We can't divide by an undefined number. So we're automatically saying that x cannot equal 5 before we even start. And now we can simplify this thing. And this is no different than dividing by fractions. 2 divided by 1/2. Or I could write it 2 divided by 1/2. You remember that we save it, change it, flip it. So 2 times 2 over 1. We saved it. We change the sign to multiplication. We flip the fraction. We're going to do the same thing here. I can rewrite it as x plus 3 divided by 2x over x minus 5. All right? I can save it, change it, flip it. So I'm going to save x plus 3, x plus 3. I'm going to be multiplying that by, because I'm changing that to multiplication, this flipped. X minus 5 over 2x. And again, we know now how to multiply these. We've done this, all right, in the previous one. So x plus 3 times x minus 5, we just got to FOIL. First, inner, outer, last, right? So x squared minus 5x plus 3x minus 15 divided by 2x. And again, we can combine like terms up top. Minus 5x and 3x. So x squared minus 2x minus 15 divided by 2x. The one final thing to do is to determine what other x value cannot be in the denominator. What would make this equal 0? 2x cannot equal 0. Divide by 2, divide by 2. X cannot equal 0. So there's two values that x cannot equal 5, and x cannot equal 0. Okay? Example 2. Example 2, I'd like you to pause yourself And I would like you to do that in your notes yourself. Okay? And this is because the video is getting a little long and we got quite a bit of stuff to go. This is going to be where we're going to end this video, and we'll pick up on the next one next time. I hope this helps. We'll see you in class.